Welcome back, everybody. Continuing our probability unit, we're going to talk about compound events today. Compound events consist of two or more simple events. So I am spinning a spinner and flipping a coin. I am rolling a die and playing rock, paper, scissors. Independent events basically means that they have no influence on each other. One does not depend on the outcome of a second. Like if I flip a coin, it doesn't change the fact that I can roll 6 possible numbers on my die. Or I have 3 choices in rock, paper, scissors, and that does not affect the fact that my spinner has 5 sections that it can possibly land on. So those are independent events. Dependent events are when they are influenced. This most happens because of not replacing the object back in. So this is when you would be choosing a red marble out of a bag of marbles and keeping it in your hand, then picking another marble. Because you kept the marble in your hand, you've changed the possibilities, you've changed the outcome potential, you have changed the probability of that second grab for a marble. If you are using a deck of cards and you pick out the Queen of Spades and you keep it in your hand, that means you now only have 51 cards in your deck. So it changes the total number of outcomes and the probability of other events occurring. So replacing or non-replacing, for the most part, are going to be your cues if it sounds somewhat close to if they're dependent or independent. Examples. Jessica can choose from a turkey, tuna, salad, or soup. She can choose juice, milk, or water. If she chooses a lunch and a drink at random, what is the probability that she chooses a sandwich of either kind and juice? So there are 2 sandwiches out of the 4 main options. Turkey, tuna are sandwiches, and then you have a salad or soup. So there's 2 of those out of 4 possibilities. Again, we want them to be in simplest form, so that'll be 1/2. The probability that she gets juice to drink. Well, there's juice, milk, or water. So there's 3 possible choices, and only one of those is milk. So that's 1/3. So our probability of a sandwich and juice, we multiply them together. We're always multiplying when we're talking about compound events with probability. So 1/2 times 1/3 is 1/6. 1 times 1 is 1. 2 times 3 is 6. So we have these 2 spinners, and we want the probability of spinning red and 1. Well, the probability of spinning red, there's 1 red out of 2 total colors on that first spinner. And then there's 1 out of 8 total numbers on the second spinner. Remember, we are multiplying. And so 1 times 1 is 1. 2 times 8 is 16. So that would be 1/16. Both of the events on this page are independent. Picking a sandwich and eating it does not have any effect on what she's drinking for juice, milk, or water. Same thing with our spinners. The red and blue spinner is completely separate from the numbers, so it's not going to matter what happens over on the side with our red and blue spinner. It's not going to affect what our possibilities are on the number spinner. You have a bag of marbles. So this is where I'm starting to think, okay, dependent versus independent. And I notice here that we have bold and underlined the word replace. So that means we pick it out of the bag, we look at it, and then we put it back in. So we have 5, 4, and 3. We have to add those together to know how many total marbles are in the bag. There's 12 marbles. 5 plus 4 plus 3 is 12. So there's 5 purple marbles out of 12. And then there's 4 red marbles out of 12. Well, oops, I'm sorry, there's 3 red. Let me fix that. There's 3 red. I'm going to keep that 5 twelfths, but I want to reduce that 3 twelfths to 1/4. Now I can multiply them together. 5 times 1 is 5, and 12 times 4 is 48. So it's 5/48 of a chance. And this is independent. They're independent because after I picked my purple marble, I put it back in, and it did not change the fact that there was still 12 possible outcomes for the red one. Example 4. Now we're talking about socks. And this time we're looking at without replacing. So let's start with how many socks do we have? Well, 4 plus 6 plus 2 is 12 total socks. So our first draw out of the drawer, we have 6 white socks out of 12 total possibilities. And so that's going to be 1/2. Now, if we keep that sock, okay, after 1 white sock is removed, now there's only 5 white socks, and there are only 11 socks left in that drawer. So 5/11 is my new possibility. So 1/2 times 5/11, 1 times 5 is 5, and 2 times 11 is 22. That's 5 out of 22. And this is dependent. If we would have put that sock back in, it would have been 1/2, because that was what our first probability was here. And then we put that sock back, we'd still have a half to pick a white sock again. And that would be a 1 in 4 chance of getting a white sock total versus the 5/22. Okay. For example 5, we're again talking about without replacement. This is going to be a dependent event. It's going to change after we do our first part of the experiment. Our probability would change for the second part. So we have a bag with numbers 1 through 10. The probability that the first number that we pull out is odd. Well, there would be 5 odd numbers out of the 10, which is half. If we do draw an odd number, let's say it's 3, and we keep it in our hand, then rather than 5 odd numbers out of 10 total, we would now have only 4 odd numbers out of 9 total left in the bag. So because it's without replacement, we're not pulling that, we're not putting that number we just picked back in. So we have 4 9ths for that second draw. So 1 times 4 is 4. 2 times 8 is 18. And I'm going to reduce that by a factor of 2 to 2 9ths. So 2 9ths would be our probability. All right, last but not least, we have a standard deck of cards. I want to talk a little bit about decks of cards, just in case some of us maybe haven't played cards before. There are 52 total cards in a standard deck. There are 4 suits. There's hearts, clubs, diamonds, and spades. There are 13 cards in each suit. Okay, so and the cards are 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, King, Jack, Queen, King, Ace. Sorry. So without replacement, again, means this is going to be dependent because we're changing the possible number of outcomes for our second draw. There are 4 total queens, 1 for each suit, in the deck out of 52 cards. That simplifies to 1/13. Now, if we pick a queen and we keep it, then that means there are only 3 queens left, and there are only 51 total cards now in my deck. That reduces to 1/17. 1 times 1 is 1. 13 times 17 is 221. So that probability is 1 out of 221. All right. The back part of these notes is the you try. Please complete these and bring them in for class tomorrow. Thank you so much. Have a great evening.